The second system in relation to number sense is called small exact number system, or referred often as subitizing. It means that we are able to recognize really fast small quantities visually, but also by hearing or touching objects. Perceptual subitizing is used in this case. You should be able to quickly recognize that there are 3 dots on the slide without counting them one by one. Term conceptual subitizing or groupitizing is used when we use perceptual subitizing and our addition skills together. For example, on the slide there are some dots presented. First, you might use subitizing to create 2 clusters of 3 and then add them together to get 6 as the number of dots. In order to do this, the child has to be already familiar with addition. Thus, most kindergarten age children would not profit from using subitizing in this type of task, but instead they would need to count the dots one by one. Next, you will see a set of dots. Can you use groupitizing in finding out how many dots there are in the picture? Ready? Maybe you group the dots in this way, 2 and 4, and added them together to have 6. Or this way, 2, 3 and 1, or maybe some other way. How many different ways can you count the number of dots if using groupitizing with these dots? This graph shows the average response times for enumerating a set of dots. From 1 to 4 dots, the reaction times are pretty similar, under 2 seconds, and thus in the subitizing range. When the number of dots increases, also the time to count them increases. We cannot no longer only subitize the dots, but need to use our counting skills. As with A and S, subitizing is thought to be an innate ability which develops before verbal counting in children. Subitizing speed has been found to increase up till the age around 20 years old, but it starts to decrease after that, as the result of slowing of the perceptual processes that are involved in subitizing. Do infants of 22 weeks notice when the number of objects in the display change? Like adults, infants get bored with looking at the same thing over and over again and get interested when something new is presented. Now the question is, will the infant start looking longer if the number of objects changes? In this task, the infant would see a habituation display age 1 and age 2, repeated until there was a 50% decrease in looking time averaged over 3 successive trials. Then there was a post-habituation test, PH, in the picture, using the same criterion. The results show that the infants looked longer in the post-habituation for 2 dots changing to 3 and 3 to 2, but not to 6 to 4 or 4 to 6. The number 2 and 3 are in the subitizing range, number 6 is not, and thus it would indicate that the children are not yet able to discriminate the numerosities with a ratio of 2 to 3. Some studies have investigated the relation of subitizing skills to math skills. It has been found a positive relation between subitizing and counting skills in children from 4 to 6 years old. With older children from 6 to 7 years, no relation was found when using symbolic number comparison and number line tasks. However, it has been found that those children who has developmental dyscalculia often struggle with subitizing. Thus, they need to count even small sets of objects one by one. With those children who struggle in their subitizing skills, simple games that include number patterns may be beneficial. For example, when playing domino game, the child needs to recognize dot patterns. Groupitizing can be used in learning of counting in many different ways. For example, using egg cartons, the numbers can be grouped based on 5. 6 is 5 and 1. First using manipulatives and then moving to use more visual representations of these, for example, dot cards. Numbers over 10 can be grouped based on 10. Abacus with beads of 2 colors are based on 5, so it's easier for the child to learn the numbers using grouping instead of counting all beads one by one. Finally, moving to number line tasks, which are also used when testing children's number sense and underlying representation of numbers. These tasks have been found to be related positively to children's arithmetic skills. Next, you will see an example of a number line task. This is an example of a number line task. How well I understand the numbers is estimated by how accurate my marking is. Here I need to mark 53 on the number line. 50 is half of the 100, so a bit over. This is from the study which followed children's performance using number line task. From the first picture, we can see that, for example, kindergarten-aged children estimated number 40 close to 60 on the number line. In the first grade, close to 50, and in the second grade, the actual numbers match pretty well with the children's estimations. So, as the children get older, they become more accurate in number line tasks and precise in their estimations. Here are the key concepts and topics that were presented in this video. Thanks for watching.